Okay, well, we're continuing on doing our introduction with machine learning in our first lecture. And so we talked about the machine learning definition, the general perspective of what we're trying to accomplish. And the next area that we'll look at is task experience. So there are mainly two types of experience, either looking at experimental data, considering samples, measurements, records, patterns of observations. And the second category would be structured human knowledge, which is looking at experience, expertise, heuristics, and is expressed in linguistic form, if then types of rules. For this course, we're going to be focusing on experimental data. So basically, we're going to be focusing on this first area here. So keep that in mind as we're moving forward. So what is the learning task? And so what we're going to show here is it's basically composed of several elements. And the important aspects of a quote learning from experience are remembering and adapting. So each one of those are important categories. And so we want to have the recognition of a situation and remembering the past outcomes and proceeding per se the same. So remembering and adapting. And then the third is generalizing. With past knowledge, it is helpful in analyzing similar situations. So overall, the learning machine does all three of these things: remembering, adapting, and generalizing. So the machine learning is about modification or adaptation of the decisions and actions, so actions get more accurate with experience. Machine learning is similar to animal learning, which in that it relies heavily on the notion of similarity in the search for valuable knowledge and data, and helps for the generalization to unseen situations. So that's how we go about doing learning. Well, let's get a little bit more specific about the types of learning. And so there's 4 different types. First would be classification learning. And so with this type, we categorize or classify examples with respect to the input to different categories or classes. So it's either one class or another, or one of several classes. Another type of learning is clustering. And so similar observations are grouped together. Regression is a third type where the numerical output is sought from the observation. And so we're using mathematics and analytics. Fourth, we can look at association learning, where a connection or linkage among the observation is sought, irrespective of the class value. So the focus on the first 3 types of tasks is what we'll be looking at in this course. So we won't really be dealing with association learning. Errors in learning is the measure of performance for classification and regression. So what are the outputs of a machine learning algorithm? The output of an algorithm represents the learned knowledge. This knowledge is via a model based on structural information in the data. And for the deployment of models for decision-making, it will make predictions for the assigned task via observations not in the data experience. A good model will generalize well to unseen observations by the machine during training. So here is an example of what a learning machine would look like. And so there's basically 2 parts of this. This first part deals with the training. So all the way up to here. So we have input that's put in that the machine is learning how to respond to a certain set of data. So things that are expressed in the task experience. And then we have the measures of performance. What are the expectations of the result that we would have? As a result of then we have a trained learning machine that we can then use put in some data that is not part of the task experience. And as a result, we can either do decisions or predictions of what should come out based on the capabilities of that machine. So I'll have 3 charts here that we'll be looking at things as we're drilling down. The first is artificial intelligence. AI, like machine learning, is any computer program that does something, quote, smart. All machines learning counts as AI, but not all AI counts as machine learning. So that's where we're starting to get into this next area where we're going to get more specific into machine learning. For example, rule-based expert systems, frame-based expert systems, knowledge graphs, evolutionary learning could be described by AI, but none of these is machine learning. So we have AI, then working into the next thing, we can get into machine learning. And the collection of methods for extracting, that is predictive models for data, is known as machine learning. And then we get into a more specific area. Data mining is a part of machine learning, which mainly examines real-world applications. Commercial applications and business data analysis research gravitates towards data mining. However, both machine learning and data mining are concerned with the analysis of data to find information patterns. So we talked about artificial intelligence, then we got into machine learning, and data mining is an example of that. And then we have deep learning. So deep learning is a subfield of machine learning. Deep neural networks are a set of algorithms setting new records in accuracy for many important problems. The deep refers to multiple numbers of layers in a neural network, which makes it more complex and complicated to interpret and understand, but it learns features of the data in a hierarchy. Okay, I'm going to take a break there and we'll continue on in a minute.